Today I'd like you to turn to the section on simulation. So please open up your study guides to the simulation section. Now, exactly what is a simulation? Sometimes probability situations do not lend themselves to an easy solution. So in some situations, an acceptable approach might be to run what we call a simulation. Now, a simulation is a procedure we use to create a model that behaves like a real situation. When the simulation is run a large number of times, data are collected, and then based on experimental results, an estimated probability can be calculated. So sometimes we don't know the theoretical probability to a particular problem, so we like to estimate that theoretical probability by running what we call a simulation. And a simulation basically is arriving at an experimental probability based on an experiment, and we run several trials of that experiment to come up with a stable pattern, and then we get some type of an experimental probability that we can use to estimate this theoretical probability. Now, in a simulation, we use some type of a random process to conduct numerous trials of the situation. Then we count the number of successful outcomes to arrive at an estimated probability. Once again, that's an experimental probability, and running it several number of times, we come up with an estimate for the actual theoretical probability. In general, the more trials that we have, the more confidence we can have that the relative frequency of successes accurately approximates the desired probability that we want. And the law of large numbers states that the proportion of successes in the simulation should become, over time, stable and close to the true proportion in the population. So once again, the more trials that we have of our experimental probability, the closer and closer we become, according to the law of large numbers, to the actual true theoretical probability itself. And this is the whole idea behind simulation. In simulation, we're trying to estimate theoretical probabilities that we do not know for certain, by using experimental trials here. Now let's talk about the steps in conducting a simulation. There are 7 steps required to conduct a useful simulation. The first step requires us to describe all possible outcomes. What outcomes could we expect from the problem at hand? Sometimes it's many, and sometimes it's few. Perhaps it can only be 2 possible outcomes. But in step 1, we want to make sure that we have defined all the possible outcomes that could result from our problem at hand. Once we've discussed all the possible outcomes, then we want to assign all those possible outcomes. So now we need to assign each possible outcome in our experiment to 1 or more random numbers. For example, suppose we wanted to choose a student at random from a group of which 70% participate in extracurricular activities. Now we could use a single digit where each digit simulates 1 person. Perhaps the digits 1, 2, 3, 4, 5, 6, and 7 represent students who participate in extracurricular activities. Then the remaining single digits, 8, 9, and 0, would represent a student who does not participate in an extracurricular activity. So according to the percentage that participate, 70%, we can make a number assignment to those students who participate in extracurricular activities, and then the remaining numbers are going to be assigned to the students who do not participate in extracurricular activities. Here's another example. Suppose we wanted to choose a student at random from a group of which 32% participate in band. Now here we're going to have to use double digits. And we're going to let each double digit simulate 1 particular person. Perhaps the double digits 0, 1 up to 32 represent students who participate in band. The remaining double digits 33 through 99 and 0, 0 would represent students who do not participate in band. So those are 2 examples of assignments of random digits that we could tag to the situation at hand to do a simulation. Now in step 3, we need to choose a source of random numbers. This may be as simple